Welcome to another session of JAS Networks. In today's session, we'll go through circular queue. Example of circular queue and algorithms will be discussed in this session. Circular queue. To utilize space properly, circular queue is used. In this queue, the elements are inserted in circular manner so that no space is wasted. This is an example of circular queue. Okay, that is circular queue is derived to use the space properly. This also follows FIFO pattern. Circular queue is empty if front is equal to -1 and rear is also equal to -1. Okay. Circular queue is full if rear plus 1 modulus maximum size is equal to front. That is, circular queue is empty if front is equal to -1 and rear is equal to -1. That is, front is equal to rear is equal to -1 is the situation if the circular queue is empty. Circular queue is full if rear plus 1 modulo maximum size is equal to front. This will be clear when we discuss the example. Circular queue is a modification of simple queue in which the rear pointer is set to the initial location whenever it reaches the location max size -1. That is, this is the starting index and this is the end index. Suppose values are inside this. Okay, you already have values. See, in this point it is explained that the rear pointer is set to the initial location whenever it reaches the location max size -1. Here the maximum size is 6. Max -1 is 5. Okay. So when the rear reaches, that is the rear pointer reaches the location maximum -1. Okay, see here, now here this is rear, and when it is reaching maximum -1, that is this position, and then the next step is rear point is set to the initial condition. Okay, then rear will come here. Okay, so in the example it will be clear how it will work. So this is how we are saying that no wastage of space. So if this is empty, if the 0 index is empty, no value is there, and the next and up to this location this is full, 0 is empty. Okay, this index is empty, and now this is rear. Okay, fifth index is rear. If we are entering one more element, that will occupy this 0th index because this is empty. Okay. So that is discussed in this point, in the last point. That is, if the rear pointer is set to the initial location when it reaches max size -1. That is, when it reaches max size -1, maximum size is 6 and max -1 is 5. When it reaches the fifth position, rear reaches the fifth position, then the rear will go to the initial location, that is 0. Okay, so that is it. So that is about what is circular queue. So two algorithms. The first one is insertion algorithm, that is NQ. Here you are having an example. Okay, so we'll write numbers in this, and before that we'll go to the algorithm. Okay, if front is equal to -1 and rear is equal to -1, then if this is the case, that is no elements are there, the list is the circular queue is empty. Okay, then we are going to insert an element into that. Okay, then what will happen? See, this is the situation. If this is the situation, that is, it is empty, both are -1, front is equal to -1 and rear is equal to -1, and we are going to enter the element. So both will point to, rear and front will point to 0th location, right? So that is what, set front is equal to 0 and rear is equal to 0, and then first you have to point to that particular location, then in that location we are entering the item. That is the step. See, set A of rear is equal to item. Okay. Then another case, else if front is equal to rear plus 1% maximum size. See, here you are having elements. That is, suppose here I am having 5. Here it is 10. Here it is 2, 7, 9, 15. Okay, if this is the case, come to this point. If front is equal to rear plus 1% maximum size, say this is rear, okay, this is rear and this is front. So if this is the case, that is front is equal to rear plus 1% maximum size. What is rear? 5. 5 plus 1 is 6. Okay, 6 modulus maximum size is 6. See, 1.0. So the value is 0, right? So if front is equal to rear plus 1% maximum size, see this, consider the example, okay? Here rear is this point and front is this point, and if front is equal to rear plus 1% maximum size. See this formula, front is equal to 0 you will get, okay? See, both are same. So that is the situation, means print overflow. That means the circular queue is full. See this, because after this, in the front location you are having the value 5 and in the rear you are having the value 15. If one more element we are planning to enter, means no space is there. So what is the value of front? Rear plus 1% maximum size. If this is the case, it is full. And another case, that is space is there. The first case is no value was there, you have entered the value and rear and front are set to 0. Second case is overflow. Okay. Next is you are having values. I'll show you. Say suppose this is having 5, 10, 12, 15. Okay. This is front and this is rear, right? See this set, and here you are going to enter one more item. So space is there. So what you will do? You will enter in this location. Okay. What is the value of that? Index is 4. So if this is the case, the position of the new rear, okay, will be rear plus 1% maximum size. This is the formula. So rear plus 1 is 3 plus 1 4, 3 plus 1 percentage maximum size. Maximum size is 6. Okay. So 4% 6. 4% 6 is 4 itself. Okay. 4 modulos 6. It is 4 itself. See, you got the location and now you are entering the item there. Say A of rear is equal to item. So suppose you are going to enter 20, means enter there 20 and this is rear. Okay. So this is the case. Hope this is okay. That is insertion algorithm. If front is equal to -1 and rear is equal to -1, set front is equal to 0 and rear is equal to 0, and in that location you are entering the item, and the overflow situation, there is no spaces there, so you have to check whether space is there. For checking that, go through this formula. Okay, front is equal to rear plus 1% maximum size. If this is the case, then this overflow, no space. And if space is there, so what you have to do, you have to increase rear value using this one, and then in that particular rear value we are going to enter the new item. Okay, so this is about insertion. Next is deletion algorithm. So for the deletion algorithm, first you have to check whether the list is circular queue is empty or not, because you are going to delete it. So before deletion you have to check whether the circular queue is empty or not, if any value is there. Okay, so without value, if no value is there, we cannot delete anything from there. So that situation is underflow. So that is here. If front is equal to -1 and rear is equal to -1, we know the situation is empty, and that is underflow and exit. Okay. And next, else if front is equal to rear. See this? Front is equal to rear. This is front and this is also rear. Okay, rear and front both are same. That is what given here. That is only one element is there. If you are having only one element, if front is equal to rear, then that element, the element in that particular location, see A of front, is stored into item, and then what will happen? The item is deleted and then front will be reduced. That is, we have to show that it is empty. So empty situation is front is equal to rear is equal to -1. Okay. Next, else some other situation. That is, you are having full element. Okay. Here you are having 1. Here you are having 5, 10, 8, 9 and 6. So if this is the case and you are going to delete the element, remove the element. So this is front and this is rear. Okay. So always we know that circular queue is always following the pattern FIFO. So first element is to be deleted. Okay, first in, first out. So this element is to be deleted and that is removed and stored in item. Okay, front of A, that element is A of front, not front of A of front, that is the front element of the array A is removed. It has been assigned to the variable item. Then what you have to do, this is removed. Okay, now then this will be front. Okay, because this has removed and now this should be the front. So see the formula, set, it should come one step forward, that is front is equal to front plus 1% maximum size. See, before the front was 0 plus 1%, maximum size is 6. So 1%, 6, the value is 1. See this, front has been assigned to the index 1. So this is about deletion. Hope it is clear. Once again I will repeat, if front is equal to -1 and rear is equal to -1, that is a circular queue is empty, then print underflow. If only one value is there, you are removing that value and then the queue will become empty, right? So it should be changed to -1. And then if it is full, okay, and from there you are removing the first element, the element which is in the front. Okay, this element you are going to remove. Then after removing, front will jump to this location. Okay, say this, front is equal to front plus 1 percentage maximum size. If this is empty and this is also empty, and suppose this is front, okay, this is front. Now you are supposed to delete this element, okay. So when this will be deleted, front will naturally come here. See, front plus 1 percentage maximum size. Front is 2, 2 plus 1. That is 3 percentage 6. So if it is like, if the situation is like that, that is 3 percentage 6. That is if the numerator is smaller than the denominator. 3 percentage 6. Okay. 3 by 6, consider the remainder. That is what 3 percentage 6 is about. Okay. So if this is the case, you have to consider the numerator as the answer. See, the front is shifted to this location. Okay, this is deletion algorithm. So in today's session, we have gone through what is circular queue, what is how you can insert into circular queue, what about the front and the rear pointers, and how we can delete from the circular queue. Hope it is okay for you. Thank you.